2, isolate airborne or wire fraud signal, active signal. Okay, there's several things you're going to have to do to find a device active signal if you don't have high quality measuring devices. You need like a really badass, maybe like some kind of box, okay? And you need to do this test as a professional. You need to put your device in a really thick, dense box that is more like maybe like polystyrene or whatever that stuff is, a big rubber box or something like that, a really hardcore rubber box. It needs to be rubber, okay? And then somewhere along the lines you also might put magnets around it too, okay? Because magnetic fields also conduct light. So if either way, your magnetic field won't necessarily go into the box if it's just Earth's magnetic field, so that's not as much of a threat. But in like a cell phone, say you want to test a cell phone or a small computer with a small screen, and you want to test to see if it's got an illegal antenna or illegal communications or something like that, you basically have to set it up to run and put it in this box that is really thick. Could be made of several different types of material, but try rubber or cement or something like that, you know, something very non-conductive. And then when it stops receiving its frequencies, you'll know because it will make a sound. So you need to set it up with a frequency detector, okay? And you need to know how to detect small range, high frequency, okay? The way you do this, very difficult thing to do, okay? It's all about taking the highest voltages at a certain time. The highest voltages at a certain time, the peak voltages of the air, and separating them with an oscillator. The best oscillator you can get is essentially, hold on, I need to plug my phone in, we're losing power here. Okay, the best oscillator you can get is essentially an electron beam, okay? Electron beams are going to be your best. Otherwise, if you want another kind of oscillator, you're going to be using an X-ray, what you call a photomultiplier, or tube, X-ray tube, or you're going to be using a gamma ray tube, which is not made by an oscillator, but made by the chaotic event of an electron in a vacuum upon the surfaces of positive and negative conductors. So, and two different kinds of material, and they have anvils, and they have specific electron frequencies when they have a certain rating. There's other materials that might work. They also use other materials like copper and aluminum, and you can probably, I don't know about aluminum as much, but either way it doesn't matter as long as the electron vibrates the frequency when it hits the surface, then it vibrates. Then what you do is you collect that frequency and you power an oscillator to time a moment where a signal is drastically amplified or drastically reduced upon the event of a calculation of a high frequency, which means that you have to divide in math the very moment of the physical event of the difference between a binary up and a binary down between any photonic signal. You catch that into an antenna, becomes an oscillator. You divide it down, multiply it back up, and it becomes your oscillator for your CPU. Most likely you would want to use an electron beam, because X-rays and gamma rays could be harmful. Either way, they're already present in the air and around you someplace, so at least X-rays are. Gamma rays may not be as prevalent, but X-rays are. Other rays. Take the highest signal and the very peak voltage, divide it directly into half. And when it's at half, you're directly going to divert it, transduce it into an on and off pulse. When you do, it will stream as an oscillator, as a power circuit from an amplifier. Then you can use it as an oscillator for a circuit. So, basically, you do this, okay? You can use that to detect and test a detector, simply. You can reverse engineer or pro engineer the product that detects the frequencies coming into your machine while it's in the insulated box. Okay, and if there are any transmissions in or out of a running machine that equal any one given divided frequency, especially of gigahertz, of like cell phone towers or high Wi-Fi or anything like that, if you measure the peak voltage, the peakest voltage compared to the outside, compared to the inside, and anything is running at that peak voltage, you're automatically going to say, oh, okay, yeah, there's a signal trying to transmit out from this device while it's being plugged in. And you're going to have to use a battery. It's going to have a battery. Cell phone's easier to do than like a desktop or a laptop, but a laptop can be done. So you want to investigate all that. Test it for peak voltages. Anything that increases in the dark, especially if it's cold, you may have to cool the temperature as well. Anything that rises to the level that's ambient air from the common communications that are around you. There's a massive amount of communications around you, and there's going to be a drop because the material that you're going to have is also going to have a temperature. So it's going to have around about some kind of ambient temperature, which is also energy, okay? So it just works in a different geometrical vector. How you collect it as an ambient energy into a transducer, which is a transistor amplifier and some circuitry. So like you collect that, and if you break all that maximum frequency and volume, density, wattage into an energy bearing, where you can test to see if that maximum frequency is actually oscillating at a lower ambiency, you can say that if that frequency is oscillating, you're going to create a detector that causes the initial oscillator to turn on two different lights. Essentially, you can do this with um, transistors. It's a workaround. It's a bit of a circuit. Okay, what it does is it instantaneously, with maybe with a little hysteresis, catches the very one opposite of two binary pulses for frequency, catches the opposite, and quickly, with a bit of hysteresis, ramps it into a light switch where the transistor turns on and the light turns on, which means that if that signal is back-to-back binary frequency of any photon, back-to-back, you can delay it too. You can have it delay, have it oscillate in real human witnessable terms, human interface it, if you will, and it will oscillate equally back and forth between primary frequency, secondary frequency of a binary wave of a photon. Or you could say, if it doesn't work directly of one single photon, you can say it's of two different frequencies, which means that it's just simply a voltage frequency, which means that it's oscillating of a firing mechanism, which means that light is volt frequency instead of photon frequency. There's a difference. Okay, when you're measuring volt frequency, you just go down the spectrum, and you need a specific voltage frequency based on what can transmit in and out of that box. So you're going to build some oscillators. You're going to try to transmit into it, test each oscillator, and see what the levels are. It's really a systematic process, and it's going to take a while. But you can generically do this with some simple circuits. Okay, but it's really just like an AM or FM radio that you've always loved since you were a kid. It basically just is a frequency divider where you can detect not the whole band of frequency, but you can detect a fraction of 2 points of a band of a frequency, which equals the frequency. And then they may not equal all of the variety of moments of the frequency, but if that moment of a binary is back-to-back 0 and 1, or both 1, how you say that in a specific amount of time based on your division abilities of frequency and ambient frequency, if you know how to divide that down as a voltage divider, specific voltage division, you can collect any frequency in part based on exactly how it fires a voltage. That's all you need to do to test to see if there's a voltage coming from an instrument. Okay, so that's all it is. Just divide up some transistor circuits and maybe find you an oscillator, like especially an electron beam, and fire it into a PNP transistor on the base and collect the electron beams at a high rate of coulombs charge into a vacuum tube of electron beams, and you have yourself the fastest computer in the world. It goes all the way up to gamma radiation. I mean, as long as you have the power to make the magnetic electron nuclear effect travel with electron volts, then yeah, it just beams it like a mother chicken. And when it does, if it crashes at a certain speed, it causes a frequency in the electron, which causes a radiation. Okay, and then when it does, that frequency equals whatever the frequency of the electron is at what power, which is nuclear. Okay, it's Coulomb's law. So that's all you do to create an oscillator to be a supercomputer basically the fastest rate of all rates. Gamma radiation, an octobit, an octobinary, 1111111110011. You know, octobinary. It's the fastest thing that physics has ever known. Besides the rate of light, besides the speed of light, rather, or rate. I prefer to say rate. Thanks. This is how you hack people and their fake computers.